As a result of the close survey that I took during the middle of the course, I'm creating this software development cycle presentation. This topic came in a close second place for the most number of votes. The presentation is by no means exhaustive, and I'm sure you'll still have questions about how software actually gets made in industry. But I hope through this presentation that you can get at least an introduction to some of the common tools and practices in developing software for industry. If you do have any burning questions, you can always post to the discussion board or email me directly, and I'll try to address your question. The topics of this presentation are for your interest only and won't be covered on any exam. To begin with, I'll cover different software development processes. First, the waterfall process, which was a very traditional method that's not commonly used nowadays. And then I'll introduce the iterative method, which is by far the most common software development process in use today. Once you have an understanding of the iterative method for software development, I'll introduce several tools which come in very handy when developing software. So let's begin by studying the waterfall software development model. I mentioned before that it's not commonly used nowadays, but it is a good place to start in understanding what happens in developing software. The model is divided into 5 main steps, and once you complete one step, you don't go back to repeat the previous one. That's where it gets the name waterfall. First step, you're gathering requirements, and those requirements in industry would be coming from customers. The customer will have a certain need that they need to fill with software. You work closely with the customer to understand what their wants and needs are. This step is very important as a business because you want to make sure that you make software that the customer actually wants. But if you think about in 339, the requirements that you gather come from a lab document. Once you're finished the requirement stage, you'll have a document which specifies all the functionality of the software. The specification will tell you what the software needs to do, and then during the design stage, which is the second step, you'll decide how you're going to do that. The design stage would include designing classes and structs that will be used to perform specific requirements in the specification. It could also include designing graphical user interfaces or also algorithms. After the design is complete, you move on to the implementation stage, where you're actually writing code. Implementation could take a long time, or it could take a short time, depending on what the project is. Once you've finished implementation, you begin the testing stage. Testing in the waterfall model would not only be detecting bugs, but also fixing them. Once the software passes all of the tests that you've written, you can move on to the maintenance phase. The maintenance phase begins when you've released the software to your customers. If you think about an operating system like Windows, Microsoft would have done many tests before releasing the operating system, but many more bugs will be discovered once the customers have the software. The maintenance step would be used to fix any bugs that are discovered after the release. The waterfall model can work very well for small projects, and for example, like the assignments that you've done in 339. However, for large software projects, it can be very difficult to gather all the requirements at one time. Similarly, being able to design an entire software system can be very difficult, and it's almost unavoidable that there will be flaws in the design. The iterative model is developed to address those shortcomings of the waterfall model. As you can see from the diagram, the steps are now performed in a cycle. Using this model, you can gather a subset of the total requirements, design, implement, and test them, and then gather more requirements as the customer desires. That's one of the main benefits of the iterative model, is that if you miss some requirements, or if you have a shortcoming in your design, you're constantly coming back and getting more feedback as you continue with your development process. That ability to deal with changes has made the iterative model the clear winner in software development nowadays. And I should add now that each time you go around the cycle, that's called one iteration, and that's why it's called the iterative model. The amount of time that it takes to complete one iteration can vary, but it's quite common to have between 3 and 5 weeks to complete one iteration. That's long enough to implement significant pieces of code, but it's short enough that you can still address changes. For example, if it took 1 year to complete an iteration, by the time you got back to gathering new requirements, there might be substantial changes, and you'll have wasted a lot of time implementing software that's no longer useful. As you can imagine, based on your experience working in pairs in 339, it can get very difficult to manage a large software project. When you have only 2 developers and one person changes a file, it's not too much trouble to email the files back and forth. But in industry, you can have teams of thousands of developers all working on the same project. Thankfully, there's a lot of tools available to help manage software projects. And that's where I'll begin explaining the tools that are available. The first is just a general software management tool. The management system would have a product backlog, or just a backlog for short, that maintains a list of all the stories and tasks that need to be completed for the product. A story can be thought of as a requirement that the customer gives you. The stories get broken into smaller tasks that developers can work on. For large projects, there could be hundreds, if not thousands, of tasks in the backlog. The software management system will also allow for iteration planning. In iteration planning, you select the tasks and stories that you want to complete for the iteration. As you perform the iteration planning, you also need to perform estimation, which is where you guess how long it'll take to complete each task. There are entire courses on estimation for software, and being able to have accurate estimates of how long tasks will take takes a lot of experience. Having accurate estimates is vital for iteration planning. When you plan the iterations, you'll make promises to your customers on what you'll deliver. If you can't complete what you promised, you risk losing those customers. A software management system will collectively manage all of these tasks together. Traditionally, the product backlog could have been just a board with sticky notes on it, but now we have software available to make things easier. There are many options for software managing and software planning, but the one that I use at work is made by Microsoft, and it's called Team Foundation Service. I'm not endorsing Microsoft, and I'd highly suggest that you choose free software tools instead of Microsoft's. But because it's what I have on my computer, I'll demonstrate using the Microsoft Team Foundation Service. Here you can see a screenshot of the product backlog in Microsoft's Team Foundation Service. From this view, you can see it's just a list of user stories. And if you double-click on the story, you can see all the individual tasks that have been planned for that story. Also, you can see which iteration they were planned to be completed in. The stories that I've shown here were all planned to be completed in iteration 4. The next feature is called the iteration board, and this shows all of the user stories, which are in the first column on the left, and then the small little boxes are the tasks for completing those stories. The tasks are divided into new, active, and closed. New are the tasks that haven't been started yet, active are the ones that developers are currently working on, and closed are the tasks that have been completed. From looking at the board, you can see the progress of the team. Another visual way of representing the progress of a team is through a burndown chart. The burndown chart shows the total amount of remaining work on the vertical axis and the current day on the horizontal axis. So as long as developers are doing what they should be, the amount of work will decrease as each day goes on. How accurate your estimates are for each task is also important. If you have poor estimates and underestimate how long each task will take, you'll see that the burndown chart doesn't decrease as quickly as it should. The goal is always to be at 0 remaining work hours when the iteration completes. Another thing that needs to be managed when dealing with software is all of the bugs that are found. So collectively, this is called bug tracking software. The bugs can be found by developers, testers, or end users. Maybe you've had an experience where a program you were using crashed and it asked you if you'd like to send an error report to the company. Those error reports would go into something like a bug tracking software package. The number of bugs that are reported can be a useful metric for the quality of your software. Because the number of bugs that are found is always increasing, it can be difficult to manage the time spent developing new tasks versus the time spent fixing bugs. There are several free software tools that are commonly used for tracking bugs. Some examples are Bugzilla, Mantis, and Track. Here's a screenshot of the bug tracker that's built into Microsoft's Team Foundation service. As you can see, each bug is given a priority and a severity level. Severity level can range from critical, or bugs that need to be fixed immediately, all the way down to low for bugs that don't have an immediate impact on the customers. The next tool I'd like to talk about is version control systems, and this can be useful for any size of company or even for your lab projects. At the most basic level, a version control system just maintains a history of all the code. So for example, if you've made some changes to a file, you can upload it to the version control system and it'll go from version 3 to version 4. If you ever make changes that cause something to stop working, you can always go back to a previous version. Version control systems can also handle changes by multiple users to the same file. In some cases, if users are modifying the exact same lines, you'll need to manually merge the files. Some of the other benefits of using version control is that you can see who made certain changes and you can always ask them for more information. You can also compare certain versions of the same file. Some common tools for version control are Subversion, which is the command svn on Linux, Git, and Team Foundation server. The version control system can be hosted on a public free website, for example GitHub or SourceForge, or it could be on a company's private server or even just on your own laptop. Version control can be useful for more than just code. For example, if you're writing reports for a course and you want it to go back to a previous version. Here's a screenshot of the version control system built into TFS. You'll see on the left something like the Eclipse Project Explorer, except these files are all now under version control. So if you select one file, on the right side you can see all the changes that have been made to that file. Initially you'll just see the comments regarding the changes that were made to the file. But if you click on one of the files, you can compare it with the previous version, and you'll see a view like this. So on the left is version 264, and on the right is version 269, or the latest version. The code in green has been added to the latest version, and the code in red has been taken out of the previous version. Another tool that gets used for large software projects is code review. And code review is where peers review your code before you submit it to the version control system. This has many of the same benefits as pair programming. For example, your peers can find bugs before you add your code to the version control system. The code review could be done in person, or it could be done by email, but nowadays the software is able to integrate right into your integrated development environment like Eclipse. If you want to get code review built into Eclipse, you'll need to download a plugin. Here's an example of a code review from Microsoft's Visual Studio IDE. Once I make a bunch of changes to files, I can request a code review, and I'll select from a list of developers who I would like to review the code. On the left you can see I selected 2 reviewers. In the lower left you'll see an overall comment that I made regarding the changes that I made in the files. The reviewers will read this and then guide their code review to check what I've done. On the right you can see that as reviewers go through the code, they can write comments. Once they finish the review, they can send all the comments back to me, and I can reply and make changes to the code based on their comments. Once I've addressed all the changes and comments, I can submit my code to the version control system. The next tool I'd like to talk about is automated build systems. And you've actually used automated build systems using Eclipse in the lab. That's a very basic system that's called Make. But for very large software projects, building a project could take hours. Rather than having a person manage all the builds, it's better to have a software package to manage your build for you. To reduce the amount of time spent building, build systems will rebuild based on the files that have been changed. A complete rebuild can be scheduled, for example, every night. The build system would be connected to your version control system and could also be made to build every time a new version of a file is checked in to the version control system. Build systems can also support complex rules. Some that are frequently used are to upload a new version to a website, or to send emails whenever a build fails. Some free examples are TeamCity and Jenkins. Here's a screenshot of the summary page for TeamCity, which we use to build our products every time we submit a new version to the version control system. From here you can see which products built successfully and which products failed to build. You can also download the latest version of the products. The last topic that I want to talk about is automated test systems. Software testing is a huge topic, and any software engineers will be taking a software testing course later on. I won't even scratch the surface of the topic, but I'll mention that there's different types of tests. For example, unit tests, which test a single unit of code, which can be usually a function. There's integration tests, which ensure that different pieces of code work together as expected. And there's system tests that test the overall system. I won't go into how to write good tests, but I'll just mention that once you write the tests, you can have an automated system to run the tests for you. The tests can be scheduled to run at specific intervals or based on events. For example, when you check in a new version of a file, you can make sure that the tests for that file run. If any of the tests fail, you'll know that you need to make changes to the file before adding it to the version control system. For the case of system tests that test the overall system as a whole, you can have the build system run all the system tests once a new version has been built. If any of the tests failed, you can have the build system email the developers to fix the problems. Here's some screenshots from the Unit Test Explorer built into Microsoft's Visual Studio. You'll usually have a summary which states how many tests passed and how many tests failed. And until all the tests pass, you won't be able to submit into the version control system. So that concludes this presentation about the software development cycle and common tools used in industry. I hope that you found it useful. And maybe you even saw something that you said, oh, I wish I had that for the labs. This is just meant as a quick introduction to some of the tools and what software development is. If you're interested, there's a variety of courses that you'll see in the coming years. Any immediate questions you have can be sent to me by email or through the discussion boards.